Hello my friends, video number 15 of my Ultimate Ladybug course. I'm Philip and in this video we will talk about Sky Matrices. We have two options here and we'll look at what is the difference. Why do we have two options and how we can use them. Let's jump right in. In the last video we discussed the psychrometric chart. Today we look at this portion here. Ladybug Benefit Sky Matrix, Ladybug Cumulative Sky Matrix, Sky Dome and Sun Path. These are very interesting tools here and we will need these quite a lot later on. We will look at it first in isolation and then we will look at it more in detail and how we can use them in the model. But today let's go through these tools first so we get a feeling of what's happening. Again, I'm using this modified weather data. I removed everything which we used before. You can just use a normal weather data if you want. We just did some changes there just to fit it better to our site, but at the end it's just the output is just the normal weather data. We have two options here. One is the Benefit Sky Matrix and one is the Ladybug Cumulative Sky Matrix. And let's see how we can explain this the best way. Okay, so this is the site. This is my this is the boundary of the site. It's very roughly 40 meters by 80 meters, maybe 100 meters on the back side. Yeah, around 100 meters. So we have the Benefit Sky Matrix. We can place this here. And we have the Cumulative Sky Matrix, and I will explain a bit, and I will explain in a bit how that actually works. They're different models, or let's say the output is slightly different. Let's keep it like that. They have very similar inputs, and we just input based on what's asked here. We need the north because our model is already northed correctly. We don't need that. We just put in the location, the temperature, and then we have the bulb temperature, the balance temperature, and the balance offset. For now, we don't need to think about that. The Benefit Sky Matrix, I can explain very quickly based on what's written here. Get a matrix represented by the benefit, get a matrix representing, it's a weird sentence. Okay, this Benefit Sky Matrix, that's how I would write it. This Benefit Sky Matrix represents the benefit or harm of a radiation based on a temperature data. Radiation benefit matrices are helpful for evaluating building massing and facade designs in terms of passive solar heat gain versus cooling energy increase. What it does, it shows you on a sphere, or it creates a sky matrix. We will not see anything first, but I will get to that. But basically shows you which areas of the sky as an average gives you harmful energy or benefit, meaning that certain areas of the sky will benefit for heating, and that also has something to do with the time, of course, of the daytime, and then certain areas of the sky you need to cool your building down. That's how I understand it. This is the Benefit Sky Matrix. But we don't need this input here, the balance temperature, balance offset. They have a default value already. You can read what's written in here. They already assume something here. So the temperature offset from the balance temperature in Celsius, where radiation is either harmful nor helpful. We need the direct radiation, which is the direct normal radiation, and the diffuse horizontal radiation. Now it turned gray, it means it already calculated it, but we can't see anything. We can also put here all of the hours of the year. This is another way to define the period, the time period we want to check. It's good that it's here so I can explain how we can do that. So instead of defining, we need to define a period. The period, that's okay. We can define a period, but instead of like having the output period, we use the hours of the year output. So we can do that. But first, let's make this visible. And how can we make this visible? By putting here a sky dome. Sky dome helps us to visualize what we're actually looking at. There is some output, but it's not visible yet. And it says here, a sky matrix object containing the radiation benefit and harm coming from each patch of the sky. This can be used for radiation study, a radiation rose, or a sky dome visualization. It can also be deconstructed into its individual values with a Ladybug deconstruct matrix component. Let's try all of this. So let's use the sky dome. This is the closest here. can place here the Sky Matrix, and whoop, voila, we have our Sky Dome. Now we can scale this thing because it's way too big. So we can look at this in this way. We can have a Sky Dome. We can also place here a center point. So if we want to have a center point, we can do this and place one here. And we can further scale it down if we need to. And we can get a bit of an understanding. Well, let's look at it from top view. We can move our point, of course, if we want. So we can look at it like this. We can look at it in 3D. That gives us the dome, actually. It gives us the dome. And now we have a very interesting output. So we have an output that says here 43 kilowatt per hour or per square meter, kilowatt hours per square meter, positive values and the negative values. And interestingly, we have negative values. What does that mean? That means, that's my understanding, by the way, it means that this area which is in the negative, I need to compensate by additional energy to cool the building or the surface. So I have a lot of energy coming from the sky, from the sunlight, and it's too much, and I need to use energy to actually compensate that. That gives me this understanding. Now let's have a closer look into this, because it's a bit tricky to understand. And again, I hope I understand correctly. There's not a lot of material online to look it up. What else do we have here? We can use this as a stereographic or a 2D plane object. So we can use here a panel, and we put in here orthographic. Then it's just a graphic of a 2D graphic. That's also possible. We can have this, or we can have. Sometimes this is probably easier to read, especially if it's printed. But yeah, you have these options. We could, of course, copy this here and have a second point, and here we just use it like this. Let's look into this, the period. That's interesting. So we can put here the month, start month and end month. This is already good for me to start looking at an output, because now I know start month is January, end month is January. So I'm measuring 1 month, January, all the days within January. If I put here 2, I would test January and February. I don't need to put anything here because I want to test from the 1st of January to the 30th of January and so on. And that's already given. That's already default. If I wouldn't put anything in the month, it would be just a period of a whole year with all days and all hours of the year. Now, this output gives me the hours of the year, and I can place this in here. And now it actually only shows a certain area. This also doesn't give me enough information. I could, of course, now increase that again over the whole year if I want. Or I look into the summer months, let's say 6 to 8. Calculation becomes more and more tricky. All right, this also shows where the sun is. The sun is not it's above the equator in the northern hemisphere. Now I want to compare the mornings. So let's check the mornings. I'll check the whole year, but in the morning. How can I do this? Just need another slider. And start day, end day we don't need to change, but we want to change the end hour. The end hour, instead of having here 24, I think it's 23. Start hour, end hour, we can see how it looks. Okay, so the end hour, it goes from 0 to 23. So the last hour would be 23, which is the hour from 11 o'clock to 12 midnight. And we can change the end hour. No, sorry. That was wrong, not the end day, the end hour. I'm testing, still not changed because I'm still testing the whole day. Now, if I, for example, want to test the morning, I can limit this here to, let's say, 10 o'clock. Now I will see only the areas within here. I could even go earlier, let's say 6. Now until 8 o'clock seems like it's all good, and then it starts to become too hot. What we know from from the thermal comfort is that it's not exactly like that. But yeah, it's just another way to look at data again. What else can we show here? We can also create a high density version of that Sky Matrix, and it's just a different model. Just need a Boolean toggle. It just becomes more defined. So the patches are smaller. Let's go back to the whole day. Let's see. Calculation time becomes much more now. Okay, interesting. Looks slightly different. Okay, so we also could put here a ground reference. This is what type of material is there. You can also specify a folder where this calculation will be stored. And now here you can decide if you want to see the cumulative radiation in kilowatt hours per square meter or the average irradiance in watt per square meter. It's then up to you. Again with a Boolean toggle, right? So can use this here. Let's go here. If it's true, it's watt per square meter. False, kilowatt hours per square meter. Again, we have the legend parameters. As we discussed already, you can change the colors. We also have the visual set. Again, this just cleans up our model. Let's go here, Ladybug. And it also cleans up. It cleans up quite a lot. It makes it nicer. We can do that for both, for the 3D version and the flat version, as I call it. And yeah, that doesn't look so bad. So this is the benefit Sky Matrix. What for me as a landscape architect, I tell me a bit about the quality of the light. So in the morning, it's gonna be super nice. It's gonna be quite nice here in the morning. When it then becomes too hot, especially if you work in the field, it might be quite different. All right, so let's look at the other one. No, well, let's look at the radiation dome and the radiation rows. I want to see the difference as well. Wow. Okay, I'm gonna get a point here. It's a center point and a scale. Let's scale this as well. I hope it's the same scale factor. Yeah, interestingly, it shows us cumulative. It's cumulative Sky Matrix. So how can you read this? Actually, what this shows is how the light of the sky plus the sunlight is falling onto an object, and in that case, a sphere. So it's the reciprocal of that Sky Matrix. So imagine you have a Sky Matrix. This is the source of your light that gets projected onto an object, and then you put a hemisphere object. That's how it's basically receives the sunlight. And the numbers here are as a total. And because we're using the benefit Sky Matrix, we have the positive and negative numbers, but as a total, not as an average. All right. So we're testing the whole year. Okay, that's good. And now the radiant rows, which I think is pretty much the same. If we now put this in here, Sky Matrix, let's do it like this. Center point. I hope the scale is again the same. Yes, it is. Oh, no, is it? I think we don't need to show this. Let's remove this here. We don't need to show this one. So let's clean up a bit. We don't need the information twice. Let's keep this, and we can organize it in this way. It's okay. I put this below. Now I borrow all these points and create a second row. So a second column, sorry. Let's use this again. Now let's look at the cumulative sky. By the way, sun path, we'll look at that as well. Okay, cumulative sky matrix. Let's do this. It's the same stuff. This is again the sky matrix. We're just adding everything, all the sunlight we're getting the whole year or this period, we're adding on top of each other. And we need to start here. North, we have the location is here, direct radiation, direct normal radiation, diffuse radiation. And by the way, this is important. The direct radiation and diffuse radiation. What is it? Direct is direct sunlight. Diffuse is all the diffuse light from the sky. We actually never talked about this. We could use a period. Let's put the same period, which is, again, it doesn't matter. It's the whole year. We can create the high density model. Let's do that. And we could change the ground reference. Let's check the ground reference. And now we can use the same here. Let's just copy everything. It becomes slower and slower and slower. Let's input these points here. We're going to select this and say 1 point. Select this one, 1 point, and last point. All right. Okay. Let's now. The only thing we need to do, we need to change the sky matrix here. Let's see what happens. It's different color, different legend color set. Is interesting because that means this information comes from the sky matrix. This is really just a tool to visualize it. We can go here and let's see the sky dome. That's quite different as well. By the way, we need to turn off all these preview and here as well. And then we can also change this here. Yeah, quite different. Two quite different outputs. So now you could say, why do I have a different output here and here? Again, so this would be, let's say you put a hemisphere in your garden, and that gets all the energy from sunlight, and that's basically what it shows on which areas you have get the most energy based on all the light, the diffuse light and the direct light. And in here, this is a bit different. It actually measures, it assumes that you have a vertical wall and then always facing the direction of the sunlight. And then so in that case, you could try to orient your building accordingly so it gains the most passive energy. Okay, let's just read out, then you get a better understanding, because I can't explain it today. I don't know why. Visualize the solar energy falling on a different direction as a rose. By default, the radiation rose depicts the amount of solar energy received by a vertical wall facing each of the directions of the compass rose. This is useful for understanding the radiation harm benefit experienced by different building orientations or the orientations with the highest peak cooling load for sky matrices of clear skies. The tilt angle can be used to assess the solar energy falling on geometries that are not perfectly vertical, such as tilted photovoltaic panels. We talked about photovoltaic panels before, and now we actually covered more than I thought we would cover, because I actually didn't thought we will get to this portion here. But yeah, that's great. So we looked at that as well. We will use the sky dome again. Don't worry, we will need it again. One more thing to say to this here. Yeah, you can change the projection again. That's what we discussed before. You can put legend parameters. You can change the units in either watt per square meter or kilowatt hours per square meter. In the next video, we will not go through the wind profile and windrows because we already looked at it. We can revisit it if we need it in one of the next stages, and we want to analyze the geometry. But actually, we don't really need this anymore. We need it later when we do wind studies and thermal outdoor comfort, which we already did in other videos. So I can point you to these videos and they will bring you forward. But because this is a Ladybug class, we will. The next thing we need to do is actually designing a space. And so we will not directly jump into direct sun hours. Kind of, yes, we will. But we will design a space based on our understanding from all what we gathered so far. And maybe wind has somehow its place in there. So let's see. All right. I hope you liked this video. Please subscribe. Think about memberships if you want to join as a member. That would help me a lot to move forward with my videos. It's not a given that I do this here, and every help counts and helps me to actually do these videos. But I will not stop, but I also cannot promise on how often I can produce videos like that. Nevertheless, stay tuned. Let me know if you have any questions. Send me text, send me questions. Questions are always good because it triggers new videos. Sometimes, not all. All right. That's it, and thanks a lot. Thanks for all my members, by the way. I have 10 members at the moment. They fluctuate, which I understand. Not everybody can afford this, and you don't have to. It's not mandatory, not at all. And I know that students who don't have a lot of funds. When I was a student, I had nothing. I had not much, nothing to lose. Then don't worry. Also, you should know when you are a member, you can always stop the membership whenever you want. All right, see you in the next video.